Hi students! It's another great day to learn mathematics. I am Miss Siti Naima Andan, your teacher broadcaster for Mathematics 7. Today, I will teach you a new lesson in math. In this new normal, remember to stay at home, study, and together, let's be makinig and matalino. Do you still remember our topic last time? Very good. We discussed about the introduction to statistics, and we also discussed the methods in collecting data. Who among you here watches the news on TV? Me too. We often see data about the COVID-19 cases, just like with this report from the GMA network. This report shows us the data for COVID-19 cases in the Philippines as of June 5, 2021 at 4 p.m. We have here the data for the new cases, total cases, and active cases. This is one of the applications of statistics in our daily life. This only means that statistics is a very useful branch of mathematics, especially nowadays. What will we do if we collected hundreds, thousands, and even millions of data? How do we summarize and organize all of those? We can organize and summarize these data using the frequency distribution table. And this is our topic for today. Our objective for today is to organize data in a frequency distribution table. Let's have first the key terms. We have table, which is a systematic arrangement of data usually arranged in rows or columns for ready reference of information. We also have the frequency distribution. It is a table that displays frequencies for the different categories, values of a counting variable or class intervals. Next, we have the frequency. It is the number of times a certain number occurs. And we have the percentage distribution. It is often used to compare two or more distributions. It is obtained by dividing the number of frequency by the total number of values, then multiplying it by 100. In formula, this is what the percentage distribution is. Number of frequency over total number of frequencies times 100. Next, we have the ungrouped data. And we also have the grouped data. We have the ungrouped data. It is the data you first gather from an experiment or study. The data is raw. That is, it's not sorted into categories, classified, or otherwise grouped. An ungrouped set of data is basically a list of numbers. How about the grouped data? It is the data that has been bundled together in categories. Since you are now familiar with the key terms related to the frequency distribution table, let's have an example on how to construct a frequency distribution. Here are the scores of the 20-item math quiz of a class. Construct a frequency distribution. We have here the data. Let's have first the frequency distribution for the ungrouped data. In the ungrouped data, remember that we do not have to categorize or classify the data that we have collected. The first step in constructing a frequency distribution table is to arrange the data given in increasing order. So, in the given data, we have 1, 4, 5, 6, 7, and so on. With this given data, we can now construct the table. In constructing the table, the first column must be the score. So you have to write the score in increasing order. So we will start with 1, up to the highest score, which is 18. And the next column would be the tally. If you observe in our given set of data, the score of 1 occurs 3 times. So therefore, our tally here is 3. We will write 3 bars. Next, we have 2. There is no score of 2, so we will not write any tally in the score of 2. Next, score of 3. There is no score of 3, so we will not write any tally here. And then we have the score of 4. How many scores of 4 are there? So we have 2 scores of 4. We will write 2 bars. And you will just continue with the rest. Next column is the frequency. In this column, we will just rewrite the tally in a numerical value. So in the tally of the score of 1, we have 3 bars, therefore the frequency is 3. And then in the score of 2, we don't have any tally, so we will write 0. Next, in the score of 3, we also do not have any tally, so we will write 0. Next, on the score of 4, we have a tally of 2. So in our frequency, we will just write 2. And you will just continue with the rest of the scores. We're done writing all the frequency in the third column. We have to sum it all and then write the total below. Next, in our fourth column, we have the percentage distribution. How do we calculate this percentage distribution? We will use the formula number of frequency over the total number of frequencies times 100. With this example, we have the total frequency of 38. So we have for the score of 1, we have the frequency of 3, and then the total number of frequencies, which is 38, and then we will multiply it by 100. So 3 divided by 38 is 0.0789 times 100. We will have 7.89 as the percentage distribution. We will also use this formula to find the percentage distribution with the rest of the data. You have to sum it all and write the total below, which is 100%. We are now done with the ungrouped data. Let's proceed with the grouped data. In the grouped data, we have to classify and categorize the given set of data. In constructing the frequency distribution table, we have step 1, get the range by subtracting the lowest score from the highest score. Remember that this is our given set of data. The lowest score is 1 and the highest score is 18. Using the formula range is equals to highest score minus the lowest score, we have 18 minus 1. 18 minus 1 is 17. Therefore, our range is 17. Step 2. Decide on the number of class interval which is appropriate to the given set of data. Most of the time, a class interval of 5 to 20 is preferred to be used. And step 3, divide your answer in step 1 by the number of classes you have decided in step 2 to determine the class width. Suppose we choose 5 as class interval. So we have 17 divided by 5 is equal to 3.4 or 4. Always round up the quotient into the nearest whole number to meet the desired number of classes. And we have the step 4. Pick a suitable starting point less than or equal to the minimum value. Our minimum value in the given set of data is 1. So we can start at 0. And then from here, we will add the class width. So we have 0 plus 4 equals 4. And then from 4, we will add the class width again. So we have 4 plus 4 equals 8. And then from 8, we will add again the class width of 4. So we have 8 plus 4 equals 12. All our answers from adding the class width to the minimum value will be written in the first column, which is the class interval or the scores. So we will write 16, and then followed by 12, then 8, then 4, and then 0. The 16, 12, 8, 4, and 0 are what we call the lower class limit. And then we have the step 5. To find the upper limit of the first class, subtract 1 from the lower limit of the second class. A while ago, we have the lower limit of 16, 12, 8, 4, and 0. And it says here that for us to be able to get the upper class limit, we will use 4, and then we will subtract 1 from it. So 4 minus 1 is 3. And we will write that in the first class. So that will be our first upper limit. Next, we have from 3, we will add 4, which is the class width. So we have 3 plus 4 equals to 7. And then from 7, we will add again the class width, which is 4. And now we have 11. And from 11, we will add again the class width of 4. So we have 15. And then from 15, add again 4. Now we got 19. And those are the upper limits of our class interval. We were now able to complete the first column of class interval using the lower class limit and the upper class limit. Now, let's proceed with the frequency. Remember that frequency is the number of times the score or the data occurs. So we will count the scores from 16 to 19. In our given set of data, 16 occurs 1, 2, 3, 4 times. And 17 occurs 1, 2, 3 times. And 18 occurs 2 times. So, if we will count them all, we'll have 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we have a frequency of 9 from the scores of 16 to 19. Next, we have 12 to 15. We will just count the scores that starts from 12 to 15. We have frequency of 7. And we will just continue for the rest of the scores. After counting the frequency for each class interval, you have to add all of this to get the end or the total number of frequency. So we have 9 plus 7 plus 12 plus 7 plus 3 is equal to 38. Our n is 38. Next, we will now proceed with the percentage distribution. Remember, in getting the percentage distribution, we will use the formula number of frequency divided by the total number of frequency, or the n, times 100. So in our first class interval, which is 16 to 19, our frequency is 9. And we will divide this to 38. 9 divided by 38 times 100. Now this is the frequency distribution table for ungrouped data and grouped data. Let us now proceed with example number 2. Using the table, compute for A. Class marks, B. Class boundaries. What do you mean by class marks? Class marks are simply the midpoints of the classes. So we have here the given table, which is the frequency distribution table of scores in a 20-item quiz of a class. We have the class interval, which consists of the lower class limit and the upper class limit. And then we have the frequency, which is the number of times the scores occur. And we have the total number of frequency, the n, which is equal to 38. And we have the percentage distribution. And now we have the fourth column of class mark. How do we complete this table? We will start with the class interval 16 to 19. For us to be able to solve for the class mark for the first class interval of 16 to 19, we will add 16 and 19 and divide it by 2. So we have 16 plus 19 is equals to 35. And then divide it by 2. So our class mark for the score of 16 to 19 is equal to 17.5. Let's proceed with 12 to 15. We will add 12 and 15 and divide it by 2. So 12 plus 15 is equal to 27. Divided by 2, we have 13.5 as the class mark. Next, we have 8 to 11. 8 plus 11 is 19, and then divided by 2 is 9.5. And then 4 to 7, we have 4 plus 7 is 11, and then divided by 2, we have 5.5 as the class mark. And lastly, we will add 0 and 3, and then divide it by 2. So 3 divided by 2 is 1.5. We have now completed the class mark for each class interval. Next is the class boundary. What are class boundaries? Class boundaries are the halfway points used to separate classes. It is obtained by subtracting the first upper class limit from the second lower class limit divided by 2. Now let's go back to the table of the scores in a 20-item quiz of a class. We have again the class interval or the scores, the frequency, the percentage distribution, and a while ago we have completed the class mark. Now let's complete this table by adding the class boundaries. Now how do we solve for the class boundaries? Get the difference of the upper class limit and the second lower class limit. With the given example, our first upper class limit is 3. And our second lower class limit is 4. So we will get the difference. We now have 4 minus 3 and then divided by 2. 4 minus 3 is 1 over 2. So that's 0.5. We will use the 0.5 to get the class boundaries for each class interval. But first, we have to get the lower class boundary. In the class interval of 16 to 19, our lower class limit is 16. So we will subtract the 0.5 from it. So 16 minus 0.5 is equal to 15.5. So this will be our lower class boundary for the class interval of 16 to 19. Next, we have the lower class limit of 12. So 12 minus the 0.5 is 11.5. So the lower class boundary for this class interval is 11.5. Next, we have 8 minus 0.5, we have 7.5. Next is 4 minus 0.5, that would be 3.5. Next, we have 0, 15.5, 11.5, 7.5, 3.5, and 0 are the lower class boundaries for the class intervals. Since we have the lower class boundary, we also have the upper class boundary. Now, how do we get the upper class boundaries? We will be using the upper class limit for each class interval. The upper class limit for the class interval of 16 to 19 is 19. And we will add 0.5 to it. 19 plus 0.5 is 19.5. Next, the upper limit for the next class interval is 15. So we will add again 0.5 to it. So we have 15.5. Next, 11 plus 0.5 is equal to 11.5. Next, we have 7 plus 0.5 is equal to 7.5. Next, we have 3.5. And these are what we call the upper class boundaries. Perfect! We have now the class marks and the class boundaries. Now that we want to construct the frequency distribution and to solve for the class marks and class boundaries, let's try this. In your self-learning module number 2 of quarter 4, we have the page 12 as your activity. You answer, let us practice. Did you find the activity easy or difficult? That's alright. There are more activities in your self-learning module. You can practice more in constructing the frequency distribution table. Just remember our key terms: table, frequency distribution, frequency, percentage distribution, group and ungrouped data, class marks, and class boundary. So that's it for today. Just remember, miracles sometimes occur, but one has to work terribly hard for them. That is from Chaim Wiesman.
Huwag matakot, be makinig and matalino. Bye-bye!